Hey, it sounds like we're about ready to go though. Our mission today is that the learner can evaluate density using some graphical analysis. That was just a fancy term. It's actually the name of a computer program. You guys probably never used it, graphical analysis, but you've used Desmos, right? Trying to make graphs and figuring out what they mean. Your sheet today, second and third math side, you guys already did the math side, both sides of that other, and this is not where we're at. This is that it?
Here.
Oh, I was there. All right. So this can be relatively quickly. I know that these things show up, so I've had to make some, what are they called? Some particle diagrams. I know that things like this show up on the first test quiz that we'll have. It'll probably be next week sometime. Not really sure when. Next week we start. Actually, we don't have a short week next week, do we? Midwinter break is weird because we have a half day. I almost just think that we'll have some sort of quiz before that. Your mission was to look at these things, and you had to evaluate it for mass, volume, and density. Did you say that A has less mass than B? Yes or no? Listen. When you take the test, make sure that you put a reason. And since all these dots are the same size and the same mass, A has more dots. Maybe that's a way. A has more dots. I don't want a big long. Yeah, that's what I meant. Thank you. I told you I'd goof up a lot in this class. All right. Volume of A versus B. Volume is just how much space something takes up. So obviously, B takes up more space. If we said bigger, couldn't we go down a rabbit hole of what do you mean by bigger? Do you mean more mass? Or do you mean more? So I just want to make sure I kind of, what about it? Because bigger, we kind of had to. Density, no calculations needed. Well, maybe, I don't know. What'd you say for the density of A versus B? Yeah, that they are equal density. All dots distributed the same. All dots distributed the same. No calculations needed. This is a concept. That concept of density is a ratio of mass to volume, but since they are all equally arranged, we're good. On to the next ones. Now we have 3 different figures. Study the matter in figure 2. Assume the particles are uniformly distributed throughout each object. Okay. A versus B. This is a B. Whoops, that's B right there. This must be a C. Your guys showed up, didn't it? Okay. A versus B. Well, B has more mass, it has more dots. I'm not going to write all the reasons, but if it were test day, you would. A versus C. C has more dots. Volume, A versus B. B takes up more space. A versus C, did you say they're equal?
Yeah.
All right. Densities now. How they're arranged. A versus B, even though they're different sizes, did you say that they are equal density? But these ones, even though they're the same size volume-wise, did you say that C has a greater density? It's even though it's the same size, it has more mass packed into that space. On to the next side. Is object E or is object F more dense? Well, E is more dense, right? E equals more dense. How would we explain that? It's got, even though they're the same size, they have more mass packed into there. Okay, now to the fun ones, the tough ones, the challenging ones. In figure 4 below, a graph shows the relationship between mass and volume for 2 different substances. Use the graph to answer questions. These also show up on the test. This sort of scale. If you put something on this side, darn, I had 2 little pieces and I've lost them. Oh well, it doesn't matter. Doesn't matter. All right, so this sort of scale. You have built a simple 2-pan balance. That doesn't look too simple. To compare masses of substance A and B. What would happen? So this is strange. They hit some questions over there in a not so obvious way. What would happen to the balance if you put equal masses of A and B in the 2 pans? They would stay balanced. Okay, what would happen if you put equal volumes of A and B in the two pans? What do you think?
A way down
Well, you think that A would go down? Would go down. So here's what I could do. I'm going to go over to the graph and just pick some numbers. I can't just tell by looking. My brain can't wrap my head around these two graphs for substance A and substance B. But I could find two equal volumes. By definition, when you put equal masses, I don't have to check the graph. If we put equal masses on a balance, they will balance. You have to check the graph for volumes. Pick a volume, any volume. It doesn't matter which one, as long as we pick the same one. I'll go with 40 and 40. Substance B would only weigh 20 grams. Substance A would weigh about 65 weight. It would have a mass of, but we say weigh 65 grams. Even though they'd be the same size, I agree. A would go down, like she said. The A would go down. That we just explained our reasoning. Okay, next part's then. So now we're doing some analyzing the graph. I'm going to get rid of this, and I like to just use this as sort of my, I can't do these in my head very well. Well, first, this isn't. Find the slope for both A and B. Remember how to do slope? The nice thing is, since they all go through 0, 0, we don't need y2 minus y1 over x2 minus x1. All we need to know is, since this is 0 and this is 0, all we need to know is 1 point. Substance A. Here's what I suggest. Find a point that's really easy to read. I'm not going to pick that point or that point or that point. I'm going to find one that crosses. You don't have to, but to me it seems the easiest is if you can find a place where it hits an intersection. You can look across and see 80, you can look across and see 50. I got 80 grams over 50 milliliters, 1.6 grams per milliliters. Okay, this is what this meant, and you probably glossed right over that, and I don't care if we write this again for the test, even though the test might say it. State the physical meaning of the slope. It means for every 1.6 grams of substance A, it would occupy 1 milliliter. Or I could say for every 1 milliliter of A, it would occupy 1.6 grams. Confusing you when I say things like that. Two different ways. I know I am because every year I do. That was A. I'm not going to write all that. Letter B. Again, find a point that's really easy to read. I think that it seems to be pretty darn close to exact. I don't know if it is.
The 2 to 21.
Do you think that was 21? All right. So here's the thing is, if you differ from mine because we estimated different, sometimes when these print, I don't know how clear it printed. When I'm looking at this, I'm just going to say it looks like 20 meets 40. I'm okay with that. If you did 21 meets 40, still okay. But I'm going to do 20 grams meets 40 milliliters. You see, what we're doing is we're finding the slope, which is rise over run. But since its slope is mass over volume, what we're really doing is figuring out its density, the density of these things. And I'm going to get 0.5 grams per milliliter. It means that a milliliter of B would have a mass of 0.5 grams. Or it means that if we had 0.5 grams of B, it would have a volume of 1 milliliter. Saying that two different ways, but these are densities. I know it said to find the slope. It's the same thing when you have mass on your rise and volume on your run. Density equals the relationship or the proportion of mass to volume. Okay, now is where I'm going to use this as my little I don't know, just as a sketch pad or something like that. What if you put 10 milliliters of A in one balance pan? What mass of B would you need in the other? I don't do these, but I'm going to use this. I'm going to use the graph, but I like to draw it up because if you're not sure what to do, I'm going to write it like this. It's said to put 10 milliliters of A. Ask yourself, how much would that weigh? Well, let's see. Let's go to 10 milliliters. Go up until it intersects with A. That's A, right? Once it does, draw that over and say, I don't know, is that a 17? Is that an 18? And I don't care which one you chose. I'm hoping that you realize if we put 10 milliliters of A in there, I need B to balance, but I need the same mass. Well, 10 milliliters of A would be about 17 grams. Since 10 ml of A is 17 grams, approximately.
It's 16.
16? I'm okay with that. I'm okay with that. Because of this? Yeah. Is 16 grams. Interesting. I could have went and done this mathematically using, but right now, I like the graph. It's about 16, it's about 17, but it is 16, I agree. Is 16 grams, we would need 16 grams of B. And that's all we have to know, 16 grams of B. It's the next one that brings us to the next level. Well, what if you put 35 milliliters of B in? Now they're not going to ask you about mass, they're going to ask you about volume. I'm going to get rid of this, and I'm going to redraw this. 35 milliliters of B. What they want to know is, what size of a piece do we have to put in A? How do I go about doing that? Well, first I got to figure out how many grams that is. 35 milliliters of B. I can't draw like it needs to be. Interesting is I'm doing it with a graph, and some of you may have technically did it mathematically. Both are okay. I'm not looking for some real exact number. I'm going up to 35 and then over. Is it 17 or 18? I'm going to just say 17. To me, it looks like this is going to have to be about 17 grams. That means I need to put a 17 gram piece in there, but that's not the question. The question says this: if you put 35 milliliters of B in one balance pan, what volume of A would you need in order to make it balance? Since 35 milliliters, I'm just saying the words that I would have written to explain my reasoning. Since 35 milliliters of B has a mass of 17 grams, and now I got to go find out what 17 grams would actually have I'm going to go find 17-ish grams and then go to A. And then I'm going to run that down and go, oh, it looks like I would need about 10 milliliters. Did you get 10? Uh-oh. I don't see a lot of...
Yeah, it's
Yeah.
10.9.
10.9, okay. So I'm not picky about these. It's the logic is like to make sure that we're on the right if we have 9 or 10 or 11 or something. I could probably go back mathematically and do it, but that just depends on how well we estimated. If you used 21, you're going to be slightly different than mine. So it's using the graph. It's saying this graph can let me find where the two of these things intersect. 35, let me just do this. 35 milliliters of B, and when I go over to A and go down, would be about 10. Yeah, I think it would be about 10 or 11. 10 or 11 milliliters of A. It's two different ways of looking at it. One way is I went through the steps. 35 milliliters is 17 or 18 grams. 18 grams is 10. But since I know I got to do that, I might as well just come over to here where it meets and go down. Water has a density of 1. Sketch the line representing water on the graph. Did you do that yet? Did you do that? I want to go get something from the other room. So if you didn't sketch that line, sketch the line for water. And then, even though we only did one page, the very next question on the next page is the last question that has to do with A, B, C, D, E, and F. So look at letter F and see if you know the answer for letter F. You don't have to keep going yet. Just see if you know the answer for letter F.